to the left or equal to 5 on a number line is going to fit that. Any number I pick that's to the left of 5. So like if we have 0, obviously 0 works. Everything to the left of 5 works. Everybody agree with that? Think about this one. What values of y, when I plug it in, are going to be less than or equal to 5? Let's think about the same values. Let's think about 4. If I put a 4 in there, okay, is it going to be less than or equal to 5? So if I put a 4 for y, so negative y, I'm going to take negative of 4. Is that going to be less than or equal to 5?
Yeah.
Will negative of any positive number, be less than or equal to 5?
No.
Put 100 in there. Yeah, put 100 in there. It's going to work, huh? Any positive number, when I turn it opposite, when I turn it negative, is going to be less than or equal to 5, right? You agree with that? Okay, so I can have, wow, that makes this graph look kind of weird, huh? Think about that. So far I've said, here's 0, and I've said all these numbers work, correct? To a bazillion. Everybody agree with that? But yet, that's saying it's got to be less than or equal to 5, but I'm going in a what?
Positive direction.
I'm going in a positive direction, yet it's supposed to be less than or equal to 5. And I've definitely gone past 5. Try 8. Right? Try 8. Would you think 8 is less than or equal to 5? No, but when I plug it in, I have to make the 8 what? Negative. So it'd be negative 8. Is negative 8 less than or equal to 5?
Yes.
All of a sudden, holy cow. All those positives are, yes?
So why are you going?
Why am I going to the right? That's what I'm asking. Why am I going to the right? No matter which positive number you pick, right? Pick any positive number you want. I have to make it what, according to that equation? I got to make it a negative. So any positive number is going to be less than or equal to 5 because I had to make it what? A negative. You with me now? It's kind of weird, but it makes sense when you start thinking about it. But then this sign is bugging you, isn't it? Doesn't this bug you? You're like, wait, it's supposed to be less than, I did, yeah. And now I'm going, what the heck, right? And you're thinking, all right, well, let's try some negative values now, okay? What if I took negative 4? Would that work?
Yeah.
What do you think, Nick? Would negative 4 work? If I put a negative 4 in this equation, remember the equation is negative y is less than or equal to 5, and I put in a negative 4, would that still work?
Yes.
What's a negative times a negative?
Positive.
But even a positive 4 is still less than what?
5.
It's less than 5, isn't it? Would 3 work? 2 work? Or excuse me, negative 3, negative 2, negative 1, would all those work? How far can I go? Oh, at negative 5, you're telling me it's going to start changing, huh? Will negative 5 work?
Yeah.
Yes. Will negative 6 work?
Yes.
No. Who said no?
There we go.
Why, Nick?
Because 6 is greater than 5.
Right. So if I take a negative times a negative, it's going to be a
Positive.
positive, and 6 is greater than 5. So it doesn't work.
That's shaking a lot more.
What did I just graph? Holy cow, I graphed something totally weird there. I thought it was less than 5. I don't even see 5 on my graph. Right? And yet somehow, what just happened? Well, really, I actually solved the equation. Okay, watch. This is actually easier than it looks. I just showed you the y, though. That's what I wanted to show you. That's why I said we're going to start with something easy so you understand the y. I'm going to divide by negative 1. Or you can multiply by negative 1. Does it matter, by the way? Is that the same as this? Will you get the same value?
Yeah.
What's negative y divided by negative 1? Y. Everybody agree with that? Negative divided by negative is a positive. Y divided by 1 is y. Okay. What's a negative times a negative? A positive. And what's 1 times what? Y. So either way, I'm going to get y. Everybody agree with that, no matter which way I do this. And I really don't care which way you do this. But think about what, if I do this to the left, I got to do it to the what? Right. But here's what's tricky with an inequality. When I multiply or divide by a negative value, you got to switch the sign of the inequality. Because you're saying I am multiplying by the opposite. See how we were doing that the whole time? Of whatever value I plug in. Well, then I need to take the opposite direction. So I have to say this is now greater than or equal to. I don't do that when I add or subtract. I only do that when I multiply or what? Divide. And I need that in your notes in 3.2. So on page, let's see here, or 2.3, sorry. Down there at the very bottom of the notes on page, what page is this on? 40. Kind of put this. This is the most important thing. If you multiply or divide by a negative value, you have to flip the sign of the inequality. You got to flip that sign. Now here I would times by negative 1. What is the value I'm going to get on this opposite side now? What's 5 divided by negative 1? Danny, what's 5 divided by negative 1?
Positive.
No. Positive divided by negative is a? Negative 5. Positive times a negative is a? What's positive times a negative? Negative 5 again. Is this what I have graphed? Yeah. Okay, all I did is really solve that and change the sign of the inequality. Okay, that's what ends up happening. But it really does make sense, even in this equation, to graph this. I know it doesn't look like it would, because you're thinking, good heck, I should concentrate on 5. But really, I need to solve the y. I need to get the y by itself, and that actually is going to make the 5 negative. Okay? All right, let's try another one. This is a little trickier. All right. Tell me, this is the important parts right here. So really focus right here, Tristan. I'm going to ask you. Ooh. What is the 3 doing to the y?
Dividing.
Yes. Very good. Very good. Everybody agree with that?
Yep.
3 is dividing the y. Okay. What is that? Addie? Addie, what's the negative 2 doing to the y? Is the negative 2 dividing the y? It's multiplying to the y. Okay, now, both those guys are right. Multiplying, dividing. Everybody with me so far? So Griffin, how do I get rid of dividing by 3? Times by 3. Okay. Briley, how do I get rid of multiplying by negative 2? Oh, Brayley. Sorry. Brayley, how do I get rid of timesing by negative 2?
We divide.
You divide. So watch. I'm going to multiply by 3 and divide by negative 2. What's that called, by the way?
Cross multiply.
No, what's it called?
Inverse?
Inverse. It's a multiplicative inverse. That's true. Usually people call that, though, a reciprocal. You ever heard the word reciprocal? That's a reciprocal. If I multiply by the reciprocal, I'm dividing by what I was timesing by, and I'm dividing by what I was multiplying by. Right? That's all you're doing when you do a reciprocal. Now, what will happen when I multiply this to this? What happens with the 3's? They divide down, right? Or some people say they cancel. I don't like to think of it as canceled, because they don't just disappear. They actually, 3 goes into 3.
You got a call.
Once. What?
You got a phone call.
Don't care. Just ignore it. Negative 2 into negative 2 goes how many times? 1. So it's really 1 times 1 times y. What's that? Y. But if I times this side by 3 over negative 2, what do I have to times this side by? 3 over negative 2. Now I got to think a little bit here. Will the 2 and the 12 reduce?
Yes.
Yes. What is 2 into 12? 6. 6 times 3 is?
18.
6 times 3 is 18, right?
Yeah.
But this is now negative 1. What's 18 divided by negative 1?
18.
Negative 18. Everybody agree with that?
Yep.
Notice what haven't I done?
What's this
I didn't put my inequality in because I have to think to myself, have I multiplied or divided by a negative?
No.
Yes.
Yes, I divided by a negative 2. Doesn't matter that you multiplied by a positive 3. Anytime I multiply or divide by a negative value, which this is a negative value, positive divided by a negative is still a what? Negative. It's a negative value. If I multiply this side by a negative value, I have to switch the sign of this inequality. So this is my answer. Okay? Anything that is less than negative 18. Now you can think this way. Think about negative 2/3 y is greater than or equal to 12 and plug in a value that is what? Less than or equal to what? Negative 18. Let's think of this something. What's less than or equal to negative 18? Give me a value.
Less than?
Less than negative 18. What is it? On a number line. Negative 19 or negative 20. I'm going to use negative 20, but I'm going to use negative 21 because it's divisible by what? 3, just because it'll make my life easier. But I could pick 19 or 20 or any of those. I'm just picking negative 21 because it's divisible by 3. I'm going to times that to negative 2/3, and I'm going to see if that's greater than or equal to 12. So 3 goes into 21 how many times? 7. Negative times a negative is a 2 times 7 is 14. Is that greater than or equal to 12? Yes. I could do 19. I could even do 18. How come?
Greater than or equal to 12.
Because it's equal to, right? So if I put in negative 18, think about that. Negative 2/3, negative 18. 3 goes into 18 how many times? What's a negative times a negative? Positive 18 is 18. Oh, sorry, I did that wrong. 6 times 2 is 12, sorry. 12 is greater than or equal to what? 12. Is that true? Yeah. So those will all work. So the key here is if you multiply or divide by a what? Negative, then it's going to create a situation where you flip the sign of the what? Of the inequality. Okay, change the sign of the inequality. A lot of kids forget to do that. Okay, here we go. You can quit that now.